On the small triangle of the steps, we know this. We're talking about these steps whereby we give going of 250. We have the rise of what of 160. So we know the width of that. So what is the base? The base is going to be what we have multiplied by what 0.25, ne?
0.22.
Multiplied by what 0.16 multiplied by what is the width of the staircase? It's 1 comma what 45, ne? The density is 2.4 and the gravity
SJ, where did you get 0.25 from?
is 250.
Is it not 220?
No, is it 220?
Yeah.
Oh, sorry, it's 220. Oh, I wrote 250 here. It's 220. Sorry. Where is it? Okay, 0.22.
Right.
Can you substitute and give me the answer?
Six comma 609.
Let's wait for the others to confirm.
With these SJ, how many decimal places must you go to before you round off?
I want to myself always, as I said before, I said 3 decimal place, you are safe.
Because in some calculations I see they round off to 3 decimal place, some calculations it's to 2 decimal place, some is to 1.
No. To be safe, it's 3 because 3 you are safe from 3. Confirmation, Kia?
Yes, I got the same.
Are you getting that 6 comma something? The same one that Mr. Shelling is getting?
600.84.
600 and what?
0.84. So the gravity, don't you say multiply by 10 to the power of minus 3?
I said you
Divided
can
by
put engineering. Okay, put it. I can press engineering, but it's okay. Just like that. Okay. Maybe that's why my material is getting different answers.
Okay. No, so if I 12 times 10 to the power minus 0, 0.6.
Press engineering.
Okay. 6,209.
Good. So now we are going to calculate. The question says what? Calculate what? Calculate the total designed and imposed load. The total design and imposed load. So please, I'm gonna erase that so that we can have a proper space. I think I should get, maybe I can, if I can have two of these things, ne? We have what? The total design load, and then we have a total what? The total imposed load, design imposed load, imposed load. Good. How do you calculate this one? It's 1,2 GN. Ne? We are given something there. That means we need to know that we are going to say what? It's 1,2. What is it? You are going to say 1,2. You add what you calculated before. You are going to combine it together. That will be your design load. Because you are going to say what? You are going to say, wait, what did you get? You said 12. The first one was what? 12,77, eh? Plus 6,606. What are you getting there?
23,255.
But I prefer writing it like this. We can just do this also, or we're gonna come back to that one if we're not getting it. We can just say W is equals to what? The same formula that we know. Don't forget to write the reference that you got it from where. What is the reference? Which slot is this one? Is it 4.2 point what? 0.2.1, eh? Where we going to have 1,2, we said 12,77 plus 6,606 plus 1,6, and then the QN, you are given something there, so you need to solve. You are going to take the imposed load that is given, you multiply it with the width, and you multiply it with the what? With the base of the staircase. So this is what I mean. We can just 1.6. The QN is what? What was the imposed? It's 2.5 multiplied by 1.450 multiplied by 2, what is it? It's 2.4, ne? 2,420, ne? It's 2420, ne?
Yes.
Good. This is what you must do here. I just want to show you this part because I know the other part you will flow, because this is the trick part. This is the trick part. The rest you will be able to do. I will explain that. What is the answer? What is the answer?
37,291.
Mama told me you're getting it.
It's like 40.1.
Yeah, you must fix how to punch your calculator, ne?
Yes.
Smell video call and then just to practice how to punch these values. Casual, I know it has some problems. You're not alone. You are getting what, Mr. Shali?
37,291.
37,291.
Yeah.
So I want us to check something, Mr. Shaling. We gotta check something. We gotta check something. Remember, you see in your book they said
'Those
okay,
the
just
live
add
load
this.
and
They did
dead
this
load.
separately. Well, you try to add
Yeah.
this. Just a 23,255 plus 14,036.
I already done that. It comes to 37,291.
Good. So that means now I heard the question says the second question they were looking for what? They were looking for the. I'm just gonna write the formula so that you can understand. I know you'll be able to do that. They said what? Calculate what? The Bmax. We know the Bmax whereby it's WL squared divided by what? 8. So now you calculated that 37, what?
291.
291. And then this is the what? You multiply the length is the base of the staircase. The length, which is what? 2, what? 4. Is it 2,4? 42, ne? Squared divided by 8. The other things is the one something that we did, but I just want to explain this in terms of calculating the value of k. Calculating the value of k. On that value of k, we know that you will come back to this and calculate yourself, ne? Calculating the value of k. We know that the formula is given as what? The Bmax. If this Bmax, that one above is wrong, even the k is going to be wrong. We know that the B, it's FCU BD squared. Now there's a depth, effective depth. Here, you see, this is a depth that we are given. This is the depth that we are given. So what's happening here? There's always so the effective depth that we are looking is starting from here to here. There's a cover that is here. So assumption there, what I told you, the cover what ranges between 25 and what is 25 and 50. So they assume 25. So therefore, you are going to take that effective depth. You're going to say a normal depth minus 1 minus 25 to get what? To get the effective depth that you are going to use there in the formula. You get it?
Yeah.
And you know yourself that calculating the lever arm on the lever arm, okay, Z equals to, it's Z equals to what? Is it
D equals 0.5
0.5
plus the square root of 0.25
minus
K over 0.9.
So this one, there's a that restriction, you know, remember, that one, okay, 95D. How do you use this formula? You only use this formula if here in this formula, when calculating the K, if your K, these are restriction, if your normal K, if your normal K is what?
Is less than K prime.
If it's less than K prime, therefore, you're going to use that formula where it has what? 0.95D. But if your K is greater than K prime, you're using the normal formula without this step. You get it?
Yes.
The other things, it continues just like that. It's something that we already know. Calculating the steel reinforcement, it doesn't change. The only thing that we're going to talk about is the selection center to center, those things. So we're gonna talk about those ones. For us to see if we do understand, there's a staircase there on exercise 1.8. Mr. Shannon, can you capture that page for those who don't have, like, okay, is using actually all those we have many of them. That's the case page from, yeah, on that exercise 1.8, all of them. That's how we're going to compile our notes. And then we're going to talk about the center to center, perhaps tomorrow, just to give you a clue. For now, let's worry about calculating the deep stuff. Are we okay?